Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Subject is matrices and calculus. Today we are going to discuss the properties of eigenvalues and eigenvectors of a matrix problems. Before going to discuss here, we need to understand what is the eigenvalue, what is the eigenvector, and again how to find the eigenvalues and eigenvector. Regarding all these things, we discussed in the previous classes. Based on the eigenvalues and eigenvectors, here today our topic is the eigenvalues and eigenvectors properties. Here the properties of eigenvalues and eigenvectors. Here first we'll discuss what is a matrix form. That means if the matrix are given, that is in the form of the matrix, and again what is the name of the particular matrix, and again the matrix eigenvalues. For example, we need to consider here the matrix is 2 by 2, that is A0 0 B. While we are going to observing this matrix is clearly the matrix is the name is the diagonal matrix because of the non-diagonal elements are zeros. While we are going to observe here the non-diagonal elements are zeros, and based upon the non-diagonal elements are zero, it is called as a diagonal matrix. Particularly the diagonal matrix eigenvalues are the diagonal elements. Here the diagonal elements are A, B. Therefore, if the matrix is according to the given matrix is satisfied the diagonal matrix, the eigenvalues of the diagonal matrix are the diagonal elements. And similarly, for example, here A, B, 0, D. Here also, while we are going to observing the given 2 by 2 matrix, the matrix is the upper triangular matrix because of below the diagonal elements are 0. It is called as a upper triangular matrix. And here also the property of the upper triangular matrix is satisfied. The eigenvalues of the upper triangular matrix are the eigenvalues are the diagonal elements. Therefore, here also the diagonal elements are, first one is the diagonal elements, the diagonal matrix A, P, and second matrix is upper triangular matrix, the diagonal elements are A, D. That means, and similarly, if the matrix is the A0, BC, here also the matrix is the lower triangular matrix. That means the above the diagonal elements are 0. Such type of the matrix is called as a lower triangular matrix. As per the property of the matrix is satisfied the upper triangular matrix, the diagonal elements are also here the eigenvalues of the matrix. That means the eigenvalues are here A, C is the matrix. That means while we are going to observing one suitable example for each one, for example the matrix is a 2 by 2, like consider it is 1 0 0 2. It is the diagonal matrix. While we are going to observing like the eigenvalues of this matrix are the 1, 2. Even if we find with the help of delta of A minus lambda I is equal to 0 with the help of the characteristic equation, here we obtain the eigenvalues are lambda is equal to 1, 2 is the matrix. And similarly, while we are going to observing in the second example upper triangular matrix, for example, we consider 1, 2, 0, 5. For example, it is a matrix is a upper triangular matrix because of here we assume that the element is the below the diagonal elements is a 0. Therefore, here also according to the characteristic equation, here we obtain the lambda is equal to the diagonal elements are the eigenvalues. In this case also we obtain that clearly the lambda values are eigenvalues are 1, 5. And similarly, if the matrix is the lower triangular matrix, for example, if we consider 1, 0, minus 1, 2, here also clearly the matrix is the lower triangular matrix because of the above the diagonal elements are 0. Therefore, here the lambda eigenvalues are 1, 2 is the values. These are the clearly by observing the matrix is the diagonal matrix, eigenvalues are diagonal elements. Upper triangular matrix are also the diagonal elements of the matrix, and again the lower triangular matrix are also the diagonal elements of the matrix. And similarly, for example, we need to assume that matrix is under the 3 by 3 matrix, and here also we consider A00, 0 to 0, 0, 0, F, and here also clearly satisfied the matrix is the diagonal matrix because of the diagonal elements only it is occur. The non-diagonal elements are zeros. And here also same like the 2 by 2 matrix. This matrix is called as a diagonal matrix. The eigenvalues of the diagonal elements are here also the diagonal elements. Means here the diagonal elements are A, D, F. And similarly, for example, the matrix is in the form of A, B, C, 0, D, E, 0, 0, F. And here also the matrix is clearly the below the diagonal elements are 0. The below the diagonal elements are 0 is nothing but it is called as a upper triangular matrix. Because of based upon the upper triangular matrix, here also the eigenvalues of the upper triangular matrix, the diagonal elements are the values. Therefore, the diagonal elements are here A, D, F. And similarly, the given matrix if it is satisfied the like A00, B, C, F 0, D, E, F, and here also the matrix is above the diagonal elements are 0. That means the matrix is said to be the lower triangular matrix. And based upon the 2 by 2 matrix and here also the 3 by 3 matrix, if the matrix is satisfied, any given matrix is the upper triangular matrix is satisfied, the eigenvalues of the upper lower triangular matrix is the here the diagonal elements. That means here ACF is the eigenvalues of the given matrix. For example, if you consider for first one the matrix is like 1 0 0 0 5 0 0 0 6. That means this matrix is a diagonal matrix. Here clearly the eigenvalues are the diagonal elements is a 1 comma 5 comma 6. For example, if the matrix is a like 1 0 0 and again 1 like 6 0 and 0 5 8 and 0 0 6 for example, and it is a clearly the upper triangular matrix because of the below the diagonal elements are 0, and here also by the property if the matrix is upper triangular matrix the diagonal elements are the eigenvalues, and in this case the eigenvalues are 1 comma 5 comma 6. And similarly, if it is a consider the matrix are the lower triangular matrix means for example 1 0 0 minus 1 2 5 sorry minus 1 2 0 0 0 7. It is clearly the matrix is the lower triangular matrix, and based upon this one the property it shows clearly the diagonal elements are 1 comma 2 comma 7 because of the diagonal elements are the eigenvalues of the matrix. And next we discuss the properties. For example, the matrix in the form of like 2 by 2 and again the eigenvalues. That means that we assume that matrix is a A. The matrix eigenvalues are for example lambda 1, lambda 2 and lambda 3. That means we assume the 3 by 3 is a matrix because of if it is a lambda eigenvalues are like the 3, that is a lambda 1, lambda 2, lambda 3. That means the given matrix is the 3 by 3 matrix. By solving the characteristic equation, for example, if you obtain the lambda values are lambda 1, lambda 2, lambda 3 because of the matrix is in the 3 by 3 matrix. And based upon this one, if the matrix eigenvalues are that given the matrix eigenvalues are minus 1 and 2 and for example 5 is satisfied for example, and again here by the property of A transpose, that means here lambda 1, lambda 2, lambda 3. That means whenever the given matrix eigenvalues are lambda 1, lambda 2, lambda 3, the particular lambda 1 is a minus 1, lambda 2 is a 2, lambda 3 is equal to 5. By applying the transpose of this matrix, here lambda 1, lambda 2, lambda 3. That means there is no change of the eigenvalues of the transpose of the matrix. That means here particularly the transpose of the eigenvalues are here also, that means no change. lambda 1 is the minus 1 and lambda 2 is the 2 and lambda 3 is the 5. That means whenever the given matrix eigenvalues are lambda 1, lambda 2, lambda 3, the transpose of the eigenvalues are no changes. The same the eigenvalues of the transpose of the eigenvalues. And similarly, k into a. That means k is any scalar value that is a non-zero number. That means that k into a, for example, k lambda 1, k lambda 2, k lambda 3, and k into a. That in place of here, we assume that k is equal to 4 is any non-zero number that is a scalar. That is a 4 into a. The eigenvalues of the matrix is k into lambda 1. K into lambda 1 is nothing but k into the lambda 1 is already it is a minus 1, that is a that k is equal to it is a 4, that is 4 into minus 1 is a minus 4, and again k lambda 2, that k into lambda 2 is equal to k is already 4 and lambda is equal to 2, that is a 8, and k into that is lambda 3, that is k is equal to 4 and lambda is equal to 5, that is equal to 20. That is the meaning of here. The eigenvalues of k lambda, ka is equal to k lambda 1, k lambda 2, k lambda 3. And similarly 4 into a, the eigenvalues of a is multiplied with 4. That means here already we know that minus 1, 2, 5, that multiplying with 4, that is minus 4, 8, 20 is the eigenvalues of the matrix. And similarly, for example, the matrix is a lambda 1, lambda 2, lambda 3, and lambda eigenvalues are minus 1, 2, 5. For example, this is the matrix is the 3 by 3 matrix, and based upon inverse of the eigenvalues, the property it shows that is a 1 by lambda 1, 1 by lambda 2, 1 by lambda 3. That means whenever the eigenvalues of the matrix is a lambda 1, lambda 2, lambda 3, the inverse of the eigenvalues are 1 by lambda 1, 1 by lambda 2, 1 by lambda 3. Here, the eigenvalues are already given minus 1, 2, 5, and based upon the inverse of the eigenvalues are 1 by lambda 1. That 1 by lambda 1 is nothing but 1 by minus 1 is equal to minus 1, and similarly that 1 by lambda 2 is equal to 1 by 2 and is equal to that is 1 by 2 is a value, and again similarly that 1 by lambda 3 is equal to 1 by 5 is equal to 1 by 5 is the inverse of the eigenvalues. And similarly, for example, a power k. That means the eigenvalues of the given matrix is a lambda 1, lambda 2, lambda 3, and a power k eigenvalues are like lambda 1 power k, lambda 2 power k, lambda 3 power k. That means the power of the eigenvalues are the given matrix eigenvalues of the power. And here, for example, a power q. That means while we are going to observe here that k is nothing but that is a 3 is a value. And here a cube eigenvalues are correspondence like that is a power k like that minus 1 whole power of 3 is equal to minus 1. And here the 2 of whole power q is equal to 8. And one more that is a 5 whole power of q is equal to 125. That is the power of the a cube is the eigenvalues. That is minus 1, 8 and 125 is the eigenvalues. Like these are the based upon the properties of the eigenvalues we need to remember. Like in the previous, that is a diagonal matrix, the eigenvalues are diagonal elements. The upper triangular matrix, the diagonal elements are the diagonal elements, and lower triangular matrix, the diagonal elements are the eigenvalues of the matrix. And here also the same, the inverse of the eigenvalues, the reciprocal of the eigenvalues, the power of the eigenvalues are the power of the given matrix eigenvalues. These are the some few properties based upon the eigenvalues are the from the given matrix. And similarly, the eigenvalues is also known as that is a characteristic roots or latent roots and proper roots, and eigenvectors is also some of the like known as characteristic vector, latent vector, proper vector corresponding to the eigenvalue that is lambda of the matrix. And based upon the definition of the eigenvalues, and here the one more important to remember, the sum of the eigenvalues is equal to the trace of the matrix. Any given matrix, like for example, the 3 by 3 matrix or 2 by 2, any matrix. With the help of the characteristic equation, for example, delta of A minus lambda I is equal to 0. For example, under the 2 by 2 matrix or 3 by 3, you obtain the lambda 1, lambda 2 and lambda 3. You get depend upon the order of the matrix lambda 1, lambda 2, lambda 3. We need to remember the property, the sum of the eigenvalues. That means that is a lambda 1 plus lambda 2 plus lambda 3 is the sum of the eigenvalues is equal to always the trace of the matrix. The trace is nothing but in the given matrix, whatever the diagonal elements are there, that we need to add that sum of the diagonal elements. That is a trace of the matrix. Here, this is very important to remember. Here always any given matrix, the sum of the eigenvalues is equal to the trace of the matrix is must and should satisfy. And similarly, the product of the eigenvalues. That means whenever the eigenvalues are like lambda 1, lambda 2, lambda 3, and again the product of the eigenvalues. That means lambda 1 into lambda 2 into lambda 3 is equal to, that means that is the product of the eigenvalues is equal to the determinant of the matrix. The determinant is nothing but that is a given matrix you need to find out. It is clearly satisfied the conditions. That means these are very important to remember. Here one of the sum of the eigenvalues is equal to always it is a trace of the matrix and the product of the eigenvalues is equal to the determinant of the matrix. And one more property we need to remember, if one of the eigenvalues of a matrix is 0, that means for example the matrix is a 3 by 3, in that the eigenvalues are for example 1 comma 2 comma 0, that means by solving the characteristic equation, for example here the eigenvalue, one of the eigenvalue is 0, that means it is a determinant is 0, that means inverse it is does not exist, because of whenever the eigenvalues, one of the eigenvalue is equal to 0, that is a that is equal to the meaning is 0, the that is equal to 0 is nothing but it is a inverse does not exist, because of inverse is nothing but as we know that adjacent of a by delta a, that delta is the denominator. If it is a delta is equal to 0, the inverse does not exist. That due to that reason, if any one of the eigenvalue is 0 is satisfied, the inverse does not exist. These are the major three important properties we need to remember while we are going to discuss. One is the sum of the eigenvalues is equal to the trace of the matrix, the product of the eigenvalues is equal to the determinant of the matrix, and if any one of the eigenvalue is 0, the determinant is 0, that means the inverse does not exist the conditions. While remembering all these conditions, we need to discuss some of the few problems. Like find the sum and product of the eigenvalues of the matrix. This is the given matrix 3 by 3. And as we know that here, while we are going to observing the matrix is a 3 by 3. The matrix is a 3 by 3. And we know that the matrix is a 3 by 3 is nothing but it is a you obtain the lambda 1, lambda 2, lambda 3 by solving the delta of A minus lambda I is equal to 0 by using the characteristic equations. But in this case, here we are going to discuss the today by the properties. And which property here it is useful. That means here I am asking the sum of the eigenvalues. Here the sum of the eigenvalues, already we know the property, that is a trace of the matrix. That means here based upon the given matrix, the sum here I am asking or finding that by the property the sum of the eigenvalues is equal to trace of the matrix. Here the trace is nothing but lambda 1 plus lambda 2 plus lambda 3 is the sum eigenvalues. The trace is the 7 minus 8 minus 8. This is the meaning of the trace. Therefore, it is 7 minus 8 minus 8 is equal to minus 9. Therefore, the sum of the eigenvalues is equal to minus 9. And the product of the eigenvalues. The product of the eigenvalues is nothing but whatever the characteristic equation, you need to find out lambda 1, lambda 2 and lambda 3. It is always that is a lambda 1 plus lambda 2 and lambda 3. By the property of the product of the eigenvalues is equal to the determinant of the matrix. Here, the data of the matrix is nothing but the value is 7 into 64, like according to as you know that 1 by 1 the 3 by 3 matrix written by. Here after the simplification, we obtain that it is equal to that is 665 is the value. This is the by using the property of the eigenvalues. One is the sum of the eigenvalues is equal to always it is a trace of the matrix, and again the product of the eigenvalues is equal to the determinant of the matrix. And next one, find the sum and product of the eigenvalues of the matrix A. Here the matrix is 3 by 3, and here also here clearly mentioned that without finding the eigenvalues. That means we should not calculate by using the characteristic equation, that is delta of a minus lambda is equal to 0. It is not required. Without finding the delta of a minus lambda is equal to 0, they are asking, we need to observe that the sum is equal to by the property of the sum of the eigenvalues always the trace of the matrix. Here the trace is the clearly that is a minus 1 1 0, therefore minus 2 1 0, that is addition of the trace of the matrix minus 2 plus 1 0 is a minus 1 is a value. This is the sum of the eigenvalues is equal to the trace of the matrix, that is the sum of its diagonal elements. And similarly product of the eigenvalues, the product of the eigenvalues is equal to the determinant of the matrix. Here the data by using the calculation, then we obtain the 45. These are the two, like sum of the eigenvalues is equal to the trace and product of the eigenvalues is equal to the determinant of the matrix. And one other, like for the matrix A is equal to 2 5 minus 1 0 3 2 0 0 4. Here find the eigenvalues of A inverse. Here A inverse means we should not calculate the adjoint of A by that A. Here by using the property of the eigenvalues we need to find out. Here while we are going to observing the matrix is clearly that is upper triangular matrix by the property. Here according to the matrix is satisfied the below the diagonal elements are 0. Therefore by the property of the upper triangular matrix the eigenvalues are clearly the diagonal elements. Here the diagonal elements are clearly showing the 2, 3, 4. Therefore, here the particularly the eigenvalues of the given matrix are A is equal to the diagonal elements. Therefore, 2, 3, 4 are the eigenvalues. And based upon the eigenvalues of the matrix is always that is inverse of the that is the reciprocal of the values are the inverse of the eigenvalues. Therefore, that A inverse is equal to that is 1 by 2, 1 by 3, 1 by 4. That means always it is a inverse is nothing but that is a reciprocal of the given matrix eigenvalues. In this case, already by the property that is it is a upper triangular matrix, the diagonal elements are the eigenvalues. Therefore, A inverse is equal to 1 by 2, 1 by 3, 1 by 4. This is also clearly by showing the property. And other one, for the matrix A is equal to 1, 2 minus 3 and 0, 3, 2 and 0, 0 minus 2. Find the eigenvalues of here 3a cube plus 5a square minus 6a plus 2 is the values. Here we need to use by using the property. Should not find out from A is equal to that is a square and again a cube and again like A. It is a by data of A minus lambda I, it is a not required. Directly while we are going to observing the problem, the matrix is clearly upper triangular matrix. By the property of the upper triangular matrix, the eigenvalues of the upper triangular matrix are always the diagonal elements. Therefore, here by the property, the diagonal elements are the like 1, 3, minus 2. Therefore, the eigenvalues of the given matrix are the 1, 3, minus 2 is the value. By using these eigenvalues, again we need to apply the property of the powers of the matrix. The powers is nothing but here we need to calculate what is the A square, what is the A cube. Therefore, it is A is the eigenvalues are 1, 3, minus 2. Here A square eigenvalues are 1, 9, 4. That means the squaring on both sides. 1 is a 1 square and 3 square and minus 2 are 4 square. That is 1, 9, that is a 4. And similarly, we need to find out A cube. That A cube is nothing but cube of the eigenvalues. That means here it is a 1 cube and 3 cube and minus 2 of whole cube. That means 1, that is 27 minus 8 are the eigenvalues of the A cube conditions. And here Already we existed, it is completed a cube and a square, and a is already we are identified, and remaining we need to find out the 2. The 2 is only single term given, that means it is required in the matrix, that is the meaning of 2 into I is the matrix. Here A is a matrix, A square is a matrix, A cube is a matrix, means it is a 2 is also required in the matrix, here multiplied with any unit matrix. Here the given matrix is a 3 by 3, that means unit matrix, the eigenvalues are the diagonal elements. Therefore, based upon the given matrix 3 by 3, that unit matrix eigenvalues are, that is 1 comma 1 comma 1, because of, if it is considered 1 0 0 0 1 0 0 0 1, it is clearly, it is a I matrix corresponding, that is a 3 by 3. Therefore, it is also clearly the diagonal elements. The diagonal elements are the eigenvalues. Therefore, it is a I matrix eigenvalues are 1 1 1 is a value. By using it is a square and a cube I, the problem is asking to find out the 3a cube plus 5a square minus 6a plus 2 into I. One by one here we need to replace in that a cube eigenvalues, a square eigenvalues, a eigenvalues, and unit matrix eigenvalues. Here it is a 3a cube plus 5a square minus 6a plus 2, that is equal to 3 into, that is a cube. The a cube eigenvalues are 127 minus 8, and a square eigenvalues are, it is clearly 1 3, that is 194, and a eigenvalues are 1 3 minus 2, and eigenvalues of the unit matrix are 1 1 1. Here, after that multiplying individually one by one the terms, here we obtain the solutions are clearly 4 comma 110 comma 10. That means here first we need to multiply 3 into 1, that is a 3. 3 into 27 is a 81, and again 3 into minus 8 is a minus 24, and similarly 5 into 1 5, 5 into 9 45, 5 into 4 20, and similarly all the values we need to multiply, and again together addition of that first term, second term, third term. Finally, we obtain the eigenvalues are 4, 1, 10, 10 are the eigenvalues of the given matrix. It is a simple and easy to interesting the problem without finding the characteristic equation, the eigenvalues. By using the property of the eigenvalues, we can find that such type of these are the equations. For example, the product of two eigenvalues of the matrix A is equal to 6 minus 2 2. That is, the matrix is given 2 minus 2 3 1 and 2 minus 1 3 are equal to, that is 16. Find the third eigenvalue. Like it is a logical problem. It is a find the product of two eigenvalues of the matrix are equal to 16. Find the third eigenvalue. Here, by using the property of the eigenvalues, we need to find out. We should not find out with the help of the, it is the a minus lambda is equal to 0. It is not required to find out lambda 1, lambda 2 and lambda 3. We need to use by using the property. Here in the problem, it is given the condition is the product of two eigenvalues. That means the given matrix is a 3 by 3. We need to assume that here the 3 by 3 matrix always eigenvalues are lambda 1, lambda 2, lambda 3. Therefore, we need to consider the eigenvalues of the given matrix is lambda 1, lambda 2, lambda 3. And moreover, here given the condition is the product of two eigenvalues are, that is a 16. That means if it is a consider out of the lambda 1, lambda 2, lambda 3, it is a product of two eigenvalues are the lambda 1, lambda 2 is equal to 16. Then we need to find the third eigenvalue. Therefore, here according to the product of the eigenvalues given the hint means we need to find out the data of the eigenvalue, data of the matrix. Therefore, the product of the eigenvalues always it is the data of the eigenmatrix. Therefore, the data is equal to, that is a 32. Out of here, lambda 1 into lambda 2 is given that is a 16. Therefore, 16 into lambda 3 is equal to, that is 32. Therefore, lambda 3 is equal to, that is a 2 is the eigenvalue. Therefore, here the problem is they are asking to find out what is the third eigenvalue. Therefore, the third eigenvalue is the 2 is the eigenvalue. And similarly, for example, find for a given matrix A of order 3, the data of A is equal to, that is 2, and 2 of its eigenvalues are 8 and 2. Find the sum of the eigenvalues. That means while we are observing this problem, given the condition is like given that data is given, we need to find the sum of the eigenvalues. As we know that one of the property, that is the sum of the eigenvalues is equal to the trace of the matrix. the product of the eigenvalues is equal to the determinant of the matrix. And here the product is given, that means lambda 1 into lambda 2 into lambda 3 is equal, that is a 32. And again by the property product is equal to data of the matrix. And again the sum of the eigenvalues we need to find out, that is a sum of the eigenvalues is nothing but lambda 1 plus lambda 2 lambda 3. While we are going to observing in this case, it is a product is given, that is a lambda 1 is equal to one of the condition is also given, lambda 1 and lambda 2, that is lambda 1 is equal to 8 and lambda 2 is equal to 2. And with the help of the condition, moreover, the data of the lambda is a data of the matrix are also given, that is lambda 1, lambda 2, lambda 3 is equal to 32. While we are going to replace this lambda 1, lambda 2 in the product, therefore, we clearly obtain that lambda 3 is equal to, that is a 2 is a value. Therefore, here the sum of the eigenvalues is equal to clearly lambda 1 plus lambda 2 plus lambda 3, that is 8 plus 2 plus 2, that is equal to 12 are the sum of the eigenvalue given matrix. And similarly, the two eigenvalues of the matrix A is equal to 2 to 1, 1 3 1, 1 to 2 are equal to 1 each. Find the third eigenvalue. That means the given matrix is order is a 3 by 3. Therefore, the eigenvalues are clearly we require lambda 1, lambda 2 and lambda 3. Here given the condition is are equal to 1 each. That means if it is a consider lambda 1 is equal to lambda 2, therefore it is a third eigenvalue, we need to find the third eigenvalue. That means since sum of the eigenvalues is equal to the trace of the matrix, that is the sum of the diagonal elements. Here lambda 1 plus lambda 2 plus lambda 3 is equal to, that is the trace of the matrix is, the given matrix trace is a 2 plus 3 plus 2 is the value. Already given the condition is equal to 1 each. That means lambda 1 is equal to 1, lambda 2 is equal to 1. We need to consider the third eigenvalue is a it is a consider. Therefore, it is a 2 plus a is equal, that is a 7. Therefore, a is equal to the value is a 5. This is the by the property of the eigenvalues we need to remember. Here given the two eigenvalues are equal, find the third eigenvalues by using the property of the sum and again the product of the data conditions. Similarly, find the sum and sum of the eigenvalues of the inverse of the matrix. That means here also we need to find by using the property of the eigenvalues by using the inverse of the eigenvalues of the problem. Here the matrix is clearly it is a upper triangular lower triangular matrix. Based upon the property of the lower triangular matrix, here the eigenvalues are the diagonal elements. Therefore, the eigenvalues are like here find the sum of the eigenvalues. That means the given matrix is the lower triangular matrix. The diagonal elements are like lambda 1, lambda 2 and lambda 3 is equal to always the lower triangular matrix. The eigenvalues are the diagonal elements, that is 1 comma minus 3 comma 2. Here the problem is find the sum. Sum means addition of the three eigenvalues 1 minus 3 plus 2 is equal to, that is a value is that is a 0. And again the inverse. The inverse is nothing but the inverse does not. Inverse eigenvalues are like by the property 1 by lambda 1, 1 by lambda 2, 1 by that is lambda 3. Here clearly 1 by 1, 1 by minus 3, 1 by 2 are the eigenvalues of the given matrix. That means the lower triangular, the eigenvalues of a lower triangular matrix are 1 comma minus 3 comma 2. Therefore, that eigenvalues of A inverse is equal to 1 by lambda 1, 1 by lambda 2, 1 by lambda 3 by the property, and sum of the eigenvalues is equal to the trace of the matrix. Find the sum of the eigenvalues of inverse. It is they are not asking to find out the inverse of the eigenvalues, directly the sum of the inverse of the eigenvalues. Whatever the inverse of the eigenvalues we completed, and based upon this inverse of the eigenvalues we need to addition. That means 1 plus like minus 1 by 3 and again plus 1 by 3. The required solution is it is a 7 by 6 is the value. And one other the important property, if 2 comma 3 comma 4 are the eigenvalues of A, then find the eigenvalues of adjacent of A. That means while we are going to observing the previous property, it is not covered, but we need to understand, as we know that adjacent A is based upon the inverse of the matrix. That means A inverse is equal to, as we know that is the adjacent of A by delta A. But in this problem, they are asking to find out what is the adjacent of A. The adjacent of A is nothing but inverse into the data of the matrix. Here given the eigenvalues are the given matrix 2 comma 3 comma 4. Here the by the property again the we required the product. The product is nothing but the data of the matrix. Here the product is 2 into 3 into 4, that is nothing but 24 is a product of the eigenvalues, that is a 12, and 8, that is a 12, 8, 6, and inverse is nothing but the reciprocal of the eigenvalues, that is 1 by 2 1 by 8, sorry 1 by 2 1 by 3 1 by 4. And again based upon that you need to multiply, finally you obtain the 12 comma 8 comma 6. That means the product is nothing but 2 into, that is a 3 into, that is a 4, that is obtained that clearly, that is 24. The inverse is nothing but it is 1 by 2 and 1 by 3 and 1 by 4. Therefore 1 by 2 we need to multiply, that is a 1 by 2 into 24 is a 12, and similarly 1 by 2 into, that is a 1 by 3 into, that is a 24 is equal to, that is 8, and 1 by 6 into the value is 24. The final solution is, that is a, sorry, 1 by 4 into 24, that is a 6. Therefore the adjunct of the eigenvalues are 12, 8 and 6 are the adjunct of the eigen matrix eigenvalues. And similarly these are the some problems. The two eigenvalues of the matrix are equal, they are 1 by 5 and the third time, and again find the eigenvalues. And here also by the property we need to assume the third eigenvalues be lambda 3, and lambda 1 lambda 2 are the sum of the eigenvalues is equal to the trace of the matrix. The given particular matrix is 2 3 2 and again 7, and given lambda 1 is equal to lambda 2, that is already given the times 1 by 5 third, that is the meaning of we need to assume that lambda 3 by 5. Therefore lambda 1 plus lambda 2 plus lambda 3 is nothing but lambda 3 by 5 plus lambda 3 by 5 plus lambda 3 is equal to 7. By solving this we obtain the lambda 3 is equal to, that is a 5. And again already we know that lambda 3 by 5 means that lambda 1 is equal to lambda 2 is equal to 1 and lambda 3 is equal to 5. And also find the eigenvalues is nothing but, therefore finally it is eigenvalues are a is equal to 1 comma 1 comma 5 are the eigenvalues. And these are the sum based on the properties of the eigenvalues, and we need to check it like according to these are the problems. For example exercise, find the eigenvalues of the matrix, trace and determine. And again the other one, find also that formula. With the help of these are the simple formulas we need to find out without solving the conditions. Like this is under the 3 by 3 matrix we need to find the solutions. And similarly number of any problems are given by using the property based upon according to such type of, this is the method we need to find out the eigenvalues without calculating the characteristic equation. That means like data of a minus lambda I is equal to 0 is not required by using that. Sometimes like according to we discuss the given matrix is the diagonal matrix and upper triangular matrix and the lower triangular matrix, and again any like such type of the matrix are given by using the properties we need to check it, the powers of the matrix and reciprocal of the matrix and the multiplication matrix. And again like based upon some logically the problems are given we need to find out by using the properties of the eigenvalues. Like a major important is the sum of the eigenvalues is equal to the trace, and product of the eigenvalues is equal to data. Like if any one of the eigenvalue is 0 then the data of the matrix is 0. That means it is inverse does not exist. Such type of the like property we need to remember, easy to solve that any problems, and cross verification is also possibilities without using the character, like without finding by using the characteristic equation. That means data of a minus lambda is not equal to the data of a minus lambda is equal to 0. That equation is not required. That depend upon the given problem we need to find the problems. Here any other problems are given like according to like sum of the properties we need to find that. Like for example find the sum and the product, and here also we need to use by using the trace of the matrix and the product of the eigenvalues equal to data of the matrix. And again similarly other problem also find the sum and product of the eigenvalues. And again the third one is also find the eigenvalues, means it is clearly the upper triangular matrix we need to find out. And again last one, find the sum of the eigenvalues is equal to, that is a trace of the matrix, because of find the eigenvalues is equal to, here it is not particularly any matrix of this matrix, but it is simply they are asking to find out the sum is equal to the trace of the matrix. It is a 2 3 1 2, that is a 7 is a matrix. and like this are given, we need to use by using the properties of the eigenvalues. And further, any required the doubts in this particular PPT, we need to give the reply. We need to resolve in the solutions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.